Hello and welcome to the Applied Machine Learning pre-course information session. We're just going to take a couple minutes and wait for people to arrive. And in the meantime, if you're just arriving, before we get started, I would love to hear where you're from, where you're tuning into this from, and just introduce yourself and where you're from in the chat box. And then it's right at the start time, we'll get started. So I'll just keep repeating that for people that are arriving. Welcome to the session. If you'd like to introduce yourself and where you're from, that'd be great to hear from you in the chat box, and then we'll get started right at the start time. I'm coming to you from New York City, and my name is Ali, and I'm going to be leading today's webinar. I'll put that. We'll be getting started right at the beginning in about 2 minutes, but in the meantime, please feel free to use the chat box. I put in my own first message, and it would be great for you to get comfortable with that. If you have any questions, you'll be partially using the chat box today. So I'm in New York City. My name is Ali, and I welcome you to the webinar. I say Adrian and Aruna, Gordon and James, Saksham. Okay, well, let me just get started. I think we have the right time now. And I'm going to close down my little screen. So this is the Applied Machine Learning pre-course information session. We're so glad that you are interested in this course. My name is Alyssa Surina Dixon, and I'm going to be leading you through the introduction to what the course offers and what Emeritus offers. And I hope that you'll be really excited by this course, which I also am a course leader for. So I teach data science and applied machine learning as a course instructor with Emeritus. So just a few questions about Zoom and a few comments. If you have any audio issues, you can click on the arrow next to the microphone located at the bottom left of your screen. Just make sure your audio settings are correct. If you can hear me okay, then they are. Questions for panelists, which is me. If you have any question for me, then please use the Q&A, and that you'll find it's a little 2-comment chat sort of button that says Q&A, and that's the best way for me to see your questions while I'm presenting. You can also use the chat screen to discuss things with program support that are related to more of the background application and admissions and operations, less about the course content. But I'll talk a little more about that, and there's some point in the future when I'll say if you have a question about this, you can use the chat. Otherwise, the chat can be just a chance for you to talk about where you're from and what you're interested in the course with other people attending this session. So please feel free to use the chat just for introducing yourself and letting us know where you're from and what your interest is. And otherwise, questions would be great for the Q&A. If the group chat becomes a distraction to you, please, you can also turn it off by just clicking on the chat button, and it'll close that. So we understand if you just want to pay attention to the content itself. And so the webinar agenda goes a little bit something like this. So I'm going to introduce the faculty who are responsible for the course creation, and then I'm going to talk a little bit about Emeritus, some of the aspects of who Emeritus reaches and what kind of programs Emeritus really does. I'll go over the course overview, which is probably the most important part, is what does this course contain, what will you learn, and then also the learning journey. The last few things is the Emeritus learning experience, what you can get out of an Emeritus learning experience, and we'll wrap up with a Q&A for you. We'll leave a little bit of time for that. That's okay. So the first thing is who are involved in this course. Myself, I'm a course leader at Emeritus. I went to Columbia University for my master's program in quantitative methods for the social sciences, and I'm a data scientist in the online travel space. So I think one of the great things about this course is we usually have a lot of people coming from very diverse industries, which we'll talk about a little bit later in a couple slides from now. And people are coming from, business analytics, business intelligence, people are coming from engineering backgrounds, but there's just a real hunger to be able to use the data inside a business for extracting insights, for creating and for capturing value. And so a lot of the tools that are in this course are really applicable for people across a variety of backgrounds and roles. And as a data scientist myself, working on the ground using these things, I've had a lot of experience with both the business side of trying to figure out, what can data science do for our business and how can we make better decisions? And then also from the individual contributor side as, what do we do to learn this? And what is the type of model that I want to use here? And what are all these different models going to be able to give me as a data scientist? And additionally, like how do we best understand how these models work, how to optimize them, how to validate them, things like that. So data science is a really exciting field right now. And I think it's great to be able as a data scientist to come and work with Emeritus and with people who are excited about learning data science to not only give the content about how to do this work, but also when you do this work, when it's best to use this model, when it's best just to use business analytics, for example. So it's been really great for me to work with Emeritus and to do really fun courses like this. And I'm excited for the next group. Our faculty member is Dr. John W. Paisley from Columbia University. He's an associate professor in electrical engineering, and he's also affiliated member of the Data Sciences Institute at Columbia, which is an incredible group of people who are really on the forefront of using data science in research and in new ways. So he's got a great content for this course. Also the Emeritus faculty for the data analytics. We have Kristen Kerrer, she's faculty at Emeritus, Carmen Taglienti, Fabio Vasquez, and then Mariana Lamina. So these are people who are going to be putting together a lot of the applications and assignments. So Dr. Paisley will lead the lecture videos, and then we have a whole host of group of people who will create applications for you to understand that material better and for you to work in the material. So a little bit about Emeritus, and if you've ever taken a course before with Emeritus, you might already know this, but Emeritus partners with the best universities in the world and creates online courses for people like you. And so, I think it's one of the things for me working with Emeritus, having been at Columbia and working with Columbia myself with their executive education and working at the business school. It's really a fantastic education to be able to get, but it's not accessible to a broader global market. Oftentimes these courses that an individual school might create are only accessible to a small group of people or to alumni. And so Emeritus has really widened the accessibility for some of the great courses. And you're able to access these courses from a number of fantastic schools all over the world. And just the consistency of approach, the working with across all these schools, you see just a real strength in terms of the support that students are able to receive, the time frame in which people are able to get their questions answered. So I think that Emeritus has been able to take what's best from each of the schools and then create a platform across all of them that is so wonderful for participants and really allows you just a breadth of education, but a consistency of support and teaching and materials that really makes learning a lot easier. I see there's a question already. So Columbia Engineering partnered with Emeritus and has created this course, but Emeritus has served a lot of different schools and a lot of participants across the world. You can kind of see the type of places that participants who are using Emeritus products are coming from. We've got APAC region is 18%, MENA is 15%, Europe 15%, India 14%, LATAM 12%, and then US happens to be the biggest group of 26%. So there's just a real positive response to what Emeritus is offering across the world. And it just speaks to how adept Emeritus has become at making products that are great for people from across the globe, where the barriers to learning and to accessibility have been removed in a lot of ways. And having worked with different universities and having worked in teaching data science, I've always been very impressed with Emeritus's just support system for participants and just consistency overall. So I think it's a really great organization to work for. And the learning that Emeritus has created, the learning journeys, are really designed for completion. And a lot of us have been very excited about online education, and since the beginning, since the first courses were coming out from MIT on YouTube. But there's a difference between just getting the knowledge from a single course that you need and really completing a course of study and getting all of the elements that you need. And so Emeritus has graded assignments, simulations. You have follow-up from program support that ensures that you're keeping progress along the way, which for working business people has always been the biggest obstacle for online work, is that people are coming from families and work and doing this in their spare time to get ahead and to make progress in their careers. But, we all suffer from the time, issues where we just don't prioritize some of these things when the time gets short. And so Emeritus has really figured out how to keep people on track and make sure that they're keeping up. And then by the end of the course, you've actually completed it. And so I've seen that be a real incredible thing as well. The course completion rates on Emeritus courses is greater than 85%. So that's something to be really excited about. So we have content from leading academic institutions like Columbia, simulations where you're able to practice and develop your skills, bite-sized learning. So just making sure that none of the learning is like, a 30-minute video that you have to keep coming back to, but just really small bits of video that you can take in a piece of time, and then have a knowledge check or have something that really checks your understanding on it. Have a quiz, have an application of it. The real world applications, especially for data science, you want to be able to code this yourself. You want to be able to understand how to do it yourself. And that it takes a lot for data science. That means understanding Python, it means understanding statistics, it means understanding probability, and then understanding just the business process of how to take a problem, turn it into a data science problem, and then attack that problem using a data science solution. And so I think a real world application for a course like this is complicated, and Emeritus will help you walk through the pieces of that so that you understand all the pieces that you need to have in order to successfully solve a data science problem. There's peer-to-peer learning and feedback, and I think the discussion boards are really a great tool for the people in the course to talk to each other, to share insights and learning. I think in one of the courses that I've been working in, we have people from so many different industries. We have manufacturing and insurance, a lot of finance. We have people in the retail space, and you just hear people from a lot of different roles talking about the data that they face and saying like, I have this time series data, or I'm working to try and solve, this customer problem. And as that conversation develops, you really see a lot of the commonalities that people are facing. And there's just a lot of people with similar interests. You get, the people that take one of these courses are people that share a lot of similarities in terms of personality and interests. And so there's always a lot of fun on the discussion boards, just people interacting and sharing the things that they've found, the types of content they're looking for, the answers to the problems that they've been looking for. And that's really exciting to see. And I learned from that as a course leader, because some of the things that I may not have had interest in before, just listening to the conversations and getting involved in the conversations, it's really opened my eyes to some of the tools that people are more interested in using than the ones that I've used in the past. So I think the peer-to-peer learning and feedback is also a really big part of a course like this that's global, where you have people from across the globe who are all very interested in the same topic. And then mobile learning applications. So there are ways that you can access this course on your mobile platforms as well. And then I think grading and evaluation is the last thing. We just have a pretty deep system of grading and evaluation that is simple, but will also give you the sense of, here's what I need to do next to complete the course. So there's just not a complexity in the course where you're feeling like, will I ever be able to complete this? And what are all the things necessary? You know from the beginning what it's going to take. And as simple as it is, as you work through those pieces, you gain the fundamental expertise you need. So I do see that there's a Q&A question, and I'm going to minimize my screen for a second to be able to see it. The one problem I have with using these slides is that I can't see anything but the slide. So let me. Do it this way. So Christian, you're asking, are the learning sessions fixed, scheduled, or available anytime on demand? They're available anytime on demand. So I'll go over that in some of the learning journey aspects of when you'll receive them. So Emeritus Network, just a little bit more about the Emeritus Network before we get onto the course content. There's a network that is only available to participants of Emeritus courses. And if you pass any certified or diploma program, you can connect with this global network. You can share professional experiences, generate ideas, develop ventures, really just learn from each other and build your professional network further with a global group of people who share the same passions, the same career goals, the same fundamental tools. So that's something that's also really exciting. And then introduction to the course. And I'll just make sure, check. What kind of follow-up do you offer? This is something Sealy, I think the program support can talk about on the chat, what kind of follow-ups they do to make sure that everybody is staying on track. So I'll let program support talk about that in the chat box. So for the online classes, we have 8 to 10 hours per week of learning. So that encompasses the video lectures, the discussion boards, the assignments, the knowledge check quizzes, and it's for 5 months. So it's a pretty good amount of time. So, you know, on some weeks, the number of hours is a little bit higher depending on how complex the topic is and how much time you individually need to work through it. But on some weeks, there's kind of a little breather where you feel like, okay, I'm just reviewing and I've learned a few new skills, but it's not as complex. So there's a back and forth and a balance between a really heavy week where there's a lot to learn, and the next week might be a little bit more soft, and it's not heavy hitting every single week where you're exhausted. So it is 8 to 10 hours of a commitment, but it's not always an exhausting 8 to 10 hours. I'll say it that way. Rajesh, do you have any healthcare application projects? I think we don't have, I would say, I'm trying to think about the material that's there. I think none of the material is a specific case study on healthcare, but we do have within the course topics and within the learning, we do have discussions and side projects that are a little bit more industry specific. So people from different industries can access that data and perform the analysis on the data themselves. So because of the breadth of industries, we have data that is kind of usable across many industries. And then we have other things at different times in the latter half of the course where people can sort of develop their own, pull your data, you know, do what you want to do on the data, find an analysis that's appropriate for the data. So part of the course is learning how to analyze the data with specific cases. And then another part of the course is really trying to find new data that's appropriate to the business problems you want to solve and working through that process, the data science lifecycle on that data. So there are some times when you get something that's in your area of study or research or business, and there's sometimes where pulling that interest data is part of the course. So we have video lectures, graded assignments, discussions, and real-world data sets. I'm trying to think about whether or not we have a healthcare data set in there. I know we have sometimes like cancer data sets that we use, but I'm not sure for this one if there's a healthcare specific one. The models that we're going to be learning in the course are recommendation systems, logistic regression, decision trees, Bayesian linear regression, clustering, k-nearest neighbors, support vector machines, ridge regression. I think just basic linear regression, multivariable analysis is the first thing that we talk about. But these are some of the most important models. I think people ask us sometimes, what about neural networks? And that's not something that's in the original content, but it's something that, you know, usually gets a lot of discussion, and the actual work that we're doing in the course leads very comfortably into neural networks and helps you to break down the neural network model algorithm and use it yourself if that's something you want to do. So what makes up the course? Like, what is the learning journey? Well, in an individual week, you'll start with some faculty video lectures, and you'll have some quizzes and assignments, some knowledge checks along the way. You'll have Q&A sessions, which are office hours. We have an online office hours each week where we review some of the assignments or the quizzes or the materials, and you have an opportunity just to sort of come in and ask any questions that are relevant to you at that time. We have moderated discussion boards. There's a few a week where you have some that are on a specific topic of learning, and then others that are just for Q&A, just to ask any more questions, or if some code is not working, it gives you a chance to say, I think this is right, but it's not, it doesn't seem to be working, what's going on? And myself, course leaders, and other peers are also able then to get on the discussion and say, well, this is what I did, or this is something that I found. and then application projects. So just projects that you can sort of take and run with that are specific to your interests and will help you develop and put all these tools together into a fuller picture of data science. So Anna, so you're asking, there's a few different courses: applied machine learning, which is what we're at, applied data science, applied artificial intelligence. So what is the difference between the courses? It makes sense to do together data science and machine learning, or is it almost the same course? So data science and machine learning are two that I've done myself, and data science is, while it starts you off at the same level, it doesn't get you to the same end goal. So applied data science will help you to really analyze data. It's more of the like business analyst version of data science, whereas applied machine learning is really for people with an engineer or a math background who have a little bit more understanding of the underlying algorithms. And without that background, people can't go into this applied machine learning course because there's a certain level of linear algebra and probabilities and statistics in this course. You have to be able to understand that to code it. And so the applied data science course is for people that haven't had that same background and maybe working in business analytics or business intelligence and want to apply Python and data science where they're at, but haven't necessarily gone to the next level as far as math preparation. So that's one distinction between the course. Here in this course, you'll actually be coding the algorithms behind, underneath the model. So we'll take a model and we'll learn its, its probability distribution function, and we'll actually code that. And so we're actually figuring out, like, what is the optimization algorithm that runs this, and let's code the optimization algorithm ourselves. Sure, we can import it from scikit-learn or from one of the packages available, but we need to be able to compare, like, here's the base algorithm that we can code very simply and understand very simply. Is this really going to be able to solve our needs? Whereas in the applied data science course, you kind of are coming at, like, I know that I want to do a continuous function prediction, or I know I want to do a classification prediction. And so, here are my classification models. This is the one I'm going to try out, but it's not that deep understanding of what happens underneath the hood of that classification algorithm. And is it really going to effectively be able to solve my problem? So there's just a degree of difference as far as the math background, Anna, and I think that's probably the biggest difference. And applied artificial intelligence, I haven't taught that course myself, but I do know that it's also a little bit different in terms of it's not as, it is also as challenging and requires a little more preparation. And so applied data science, I would consider as sort of the entry ground for people that haven't had the total preparation. And in a previous world, I probably would have said applied machine learning would go first and applied artificial intelligence would be a nice next step after that, because it touches on some of the same topics, but it goes a little further and it's way beyond what most machine learning courses provide in terms of the topic scope. So that's what I would say for that. Here. So the modules, just to give you a sense of what this course has, part one is the Python for data science. So this is video content and lecture material that's developed by Emeritus versus by Dr. Paisley. And it's important because Emeritus has done a lot of these data science courses, and I've been a part of quite a few of them. And there's just been really consistent feedback about the types of things that the participants need, not only the speed of the delivery, but also wanting more, wanting a more in-depth topics on certain areas. And so we originally had a course in which the Python part wasn't actually included, and you have people that do have Python experience or have some coding experience jumping right into the second half of the course where it's machine learning coding. And the people that really didn't have a foundation in Python and functions and data types really struggled. And so then the applied machine learning course really stopped it being like let's learn Python on the fly course. And so now there's a part that's just Python for data science, which really helps you with just the fundamental Python things. It's going to give you the basic of what data science is, data types, operators, functions, and then some of the popular data science packages. This is a really calm approach to working in Python for data science. So it doesn't cover all of the functionality that Python offers, because There's a lot of object-oriented programming that you can learn in Python for websites, for software, but for specifically Python for data science, you really just need to be able to write your own functions, because that becomes the basis of writing your own algorithms or pre-processing your data before putting it into an algorithm. So a lot of the out-of-the-box data science and auto machine learning type of things that we're getting in business right now, it's people who have created Python functions to take in data, kind of look at the shape and size and aspects of the data, and to determine, oh, well, there's columns that are objects, that are string objects. And then they ask you, is this a categorical or not? There's objects that are integers, do you want them to remain as integers? Are they categoricals or not? And so people have figured out the process of, you have to look at your data, you have to figure out what kind of data you have and sort of label the data. And then you have to figure out like how to process that data, make sure there's no nulls, deal with that. Or if it's categorical, maybe take those categories and put them into dummy columns. And then, you'll run it through this, algorithm. We're kind of taking you behind the scenes and saying, well, you should be able to do that yourself in data science. So, you need to be able to look at your data, determine whether it's in the right shape or not, do something with the nulls. You need to kind of figure out, like, are there correlations here? What kind of, what's the shape of my data? Is my data, I'm doing a classification model, but like, what is the distribution of my data? These are things that are important to the underlying validity of this model that I'm using, but I need to be able to do that myself. And so sometimes for some of my colleagues that don't have a math or computer science background, we'll give them some access to some auto ML type of things, where it's like you put your data set in, and outside of your data, they'll give you a prediction, and you don't know how, you don't know why. And I think a lot of my colleagues are like, if that's so easy, then why do we need to learn anything about data science? Like, why do we need to learn how to code the models ourselves, code dummies ourselves? And I just sort of think like, well, you don't, but I think somebody behind the wheel here should be able to understand why we need to do this and what's happening under the hood here. And so I think part of the flexibility of this course is that you figure out like how to do this. And it's not that every single time you're going to write your own code. You often reuse your code, but it's that even if you choose to use an out-of-the-box scikit-learn or AutoML, you understand the choices that you're making and the trade-offs, and you can communicate those very clearly. So you have the flexibility to flex in and take something that's really quick and just say, I'm just going to run my data through scikit-learn really quickly and just see if I have enough data to produce any meaningful prediction. And then I'm going to go back and refine my own algorithm. Once I've figured out an algorithm that really makes sense for me, I'm going to refine it, develop it myself, and put it into production at my company. So I think that flexibility is something that we really aspire to. Just Adrian, is there a list that lists out the courses and modules for data science, machine learning, and artificial intelligence? I think for artificial intelligence and data science, I'll ask program support if they can provide that. Because just like I have this one that I'm going through now for this course, I think that there's probably some lists for a comparison between those, which is really good to have. So I'll ask program support to do that. So part 1, module 5 is intermediate Python, data manipulation and analysis with pandas, data visualization. And this is just the basic, being able to do things like grouping and aggregating your data, because oftentimes for machine learning applications, we need all of our data to be on one row and to have a prediction for that row. And so for a lot of us who have business data, we have, weekly data, yearly data, random data in whole tables. So you have maybe a single item that you want to predict for, but you have a lot of past understanding of that item, and you want to aggregate all that past understanding into one row so that you only have one row of information. So while it seems easy just to have, maybe a toy data set where you have, some row and you're trying to make a prediction, in the real world, whatever it is you want to predict for, you have a lot of understanding about that item across time and across, connected piece of tables from your enterprise. And so really, data science is often about trying to aggregate of information on one row and then using all that information to predict. And so being able to manipulate your data, being able to join and group together data is actually a fundamental skill that is not to be missed. So we have data manipulation and analysis with pandas. And then data visualization will just give you that basic ability to work with your data and see like what kind of relationships are there between the variables in my data, and what is the histogram of my data? What's the shape of the data of interest? Is it continuous? Is it discrete? And that moves into random variables and statistical inferences. Like a lot of people come to these courses with a pretty heavy level of business intelligence, having worked with data for a long time, but kind of forgetting what we learned in the beginning in our math preparation. What is the difference between discrete and continuous? And what is, how do we model those differently? Like, what are some basic models for discrete probability functions, and what are some basic models for continuous probability distributions? And so just kind of resetting and relaying that foundation of which models are appropriate for which types of data, that helps a lot more when we're coming into, should I do a continuous? Like, when is linear analysis appropriate? Like, when is a linear regression going to work? What are its basic tenets, and is my data going to fit into that? Do I have a lot of correlations between the columns of my data? Is my data even continuous? Maybe it's continuous, but maybe the data is only in a small range. Is it normally distributed if it doesn't have any negative values? What do I do in those cases? And so those are a lot of important questions about business data that are a little bit different when you're working in statistics classes, where you have these perfect normal distributions and the data can be anything from negative infinity to positive infinity, and you have something so ideal. In a real business case, you often have values that are only positive, that are really skewed for some reason, and so you have to sort of pick apart, like, what is the appropriate distribution for this, so that I know what kind of model I should be using to make predictions. So that's a little bit about Module 8 and 9. And then Module 10 is data cleaning, which is just a simple, like, we have to figure out how to remove nulls, how to remove duplicates. It's one of the more simple weeks, where you're just kind of getting it all together and making sure that you're able to suss out any problems in your data, like outliers or duplicates or nulls. Module 11 is exploratory data analysis. And this is a chance to just think a little bit more about what you're finding in your data and how to explore it further using pandas. Module 12 is getting started with linear algebra for machine learning. And so this is sort of like that engage, the gear in which you engage machine learning a little bit more deeply. And so it's just a review of the linear algebra that you need in order to be successful in the machine learning course. And that leads me to part 2. Part 2 is the real meat of the course, for which all of the fundamentals you learn in the beginning really prepare you. So part 2 is the applied machine learning. So this video content is Dr. Paisley from Columbia, but it's delivered by Emeritus with some applications and assignments that are created by Emeritus staff. And that's fundamental, because Emeritus staff understands the student needs and has gotten a lot of feedback about what works and what doesn't work. So the supervised learning is regression, linear regression, Bayesian methods, and then foundational classification algorithms, and then intermediate classification algorithms. And so the first section is really supervised learning, and then the second section is unsupervised learning: clustering methods, recommendation systems, sequential data models, and then association analysis clustering methods. And so I think the regression, linear regression, and some foundational classification algorithms are usually what is fundamental in a machine learning course. And so you can have an 8-week course that is just regression and classification, and just a few of those. So we really cover a lot of material in the second 12 weeks of this course. And I can say, as a data scientist who works with other data scientists, that this material is really the top of the line material as far as the understanding and the ability to code these algorithms. And even as someone who learned this in undergrad, learned this again in a master's degree, and applied it in a master's degree program, as someone who's in the data science world, doing this stuff on a daily basis, and working through algorithms on a daily basis, when I come back into this course as a course leader and I talk with you in the discussion boards about the type of problems you're solving, and maybe sometimes I'll just code something for somebody and say, oh, this is how I would do it. It's amazing to me that I go back into my work and I realize, like, wow, this is actually something that it's so fresh and it's so important, and it's such a good foundation for solving business problems. And so I think it takes, a lot of people have the business domain expertise, but don't have this fundamental understanding of machine learning and what it can do for you. So to be able to get this, I think it's a really incredible material set, and it's something that, even having been through it before and even having learned this, the freshness of it every time I go through it, it really just inspires me at work to think about my problems in new ways, and to ask questions like, okay, well, today we're going through this, or this week we're going through in the applied machine learning course, you know, this specific thing, maybe sequential models, where is it in my business day that I could be using that I'm not? So there are some problems which I already know the kind of model that I'm using to solve it, but that just being in the sort of in the woods of all of these models really makes you think like, who in the business should be using this, and like, how can I get my hands on that data and just try this out? So I think it's really exciting for that. So the learning outcomes, let me go a little bit into the learning outcomes. Move my screen a little bit so I can see this. So the first aspect is being able to define a model for your data and make the model learn. I think that's something that is probably the hardest part for typical machine learning and data science courses, is you learn data science models and then you go back to your desk and you have your work, which you do just the way that you were taught to do. But really creating data science problem questions and then figuring out what kind of shape your data has and what kind of model you would need to define to predict on that, and then actually letting that model learn from your data. I think those are the real pieces that connect these, but it's not always so clear with all courses. So being able to define a model and then make the model learn from the data you have is essential here. Being able to build regression models to predict an unknown output from a given set of inputs. I think you'll be able to do a lot of different models, but that, I think regression is kind of a universally known and loved model. And so, you know, we are going to always have inputs and outputs, and you want to find a model that will learn the relationship between your inputs and outputs, whether it's regression or classification. That's really what you're going to learn here, is to develop that understanding that all of our data generating processes out there, we're trying to find the inputs either in our domain data or in outside data that we can pull in, and we've got the outputs. We're trying to find the inputs, and then we want to create a model that will learn the relationship between inputs and outputs, and we want to define that model and understand that model and make sure the model is a valid model for both the inputs and the outputs we have, rather than just take a clunky out of the box system and just throw our data in it and just say, well, you know, I think this is a regression problem, or I think this is a classification problem. And I think a pretty good example of this is just when I first started at a company. I was sitting in on a presentation by another team who had used a linear regression to predict the probability of something happening between 0 and 100. And all of their X variables had like a high level of correlation with each other. And then the actual output variable, while it was continuous in the sense that it was like, you know, not discrete values, it was a probability that only ranges from 0 to 1, for which we have like logistic regression as a typical use case. And so just the use of linear regression without any changes to the model or any tweaks to deal with the fact that this is highly correlated data, and the output does not range from negative infinity to infinity. It's this very tiny range, and there's no link function that they were using to say, well, I want the range of 0 to 1, but I'm going to spread that out across the negative infinity range using a link function. There was nothing. It was just, I'm going to do a linear regression. And I asked, well, why linear regression? And they said, well, because classification is for just a few, if you have just a few classes like 0 or 1 or 0, 1, and 2, and we have this continuous valued function, which is from 0 to 1. And I think that kind of misunderstanding of what these models are able to do and what is actually happening under the hood of the model has led to some serious validation errors where people are saying, not only is my prediction accuracy like not that great, but the model itself has some fundamental issues, and the people who are using them don't always know that. They're just trying to remember what they might have learned in their stats or econometrics classes, but just, you know, maybe haven't realized like there's a serious issue here and I need to fix that issue. Otherwise my model isn't going to work, or it's not going to be telling me what I think it's going to be telling me. So you'll be able to define the right model for your data and understand your data a little better. And then also build a regression model, predict your outputs, create classification model to be able to categorize. And I think one common case that we use is email messages being classified as spam or not spam. I think that's a very typical use case. Develop unsupervised models like topic models or recommender systems to extract hidden patterns from large amount of data. I would say that this unsupervised model, as someone who's in the data science world, is probably the most valuable in terms of creating value out of thin air, because with unsupervised models, you're able to take a lot of data and to develop KPIs out of it, take a lot of performance data and to develop new splits to be able to view aspects of your business. And so we have a lot of, and I think one of my examples for this is, there was a time where you have the stock market and you have stocks that are all performing differently. And at some point or another, people decided, you know what, it would be a great way to look at the stock market. Let's have them by industries. Like, let's have specific stocks related to certain industries. Let's look at those as a group and see how different industries are performing on the stock market today. How did they do that? Well, I think it's a natural, we just sort of say like, well, it's intuition. Like, you need to group things that are similar together. Well, that's exactly what you want to teach computers to do. You want to take your data and say to the computer, group similar things together so that I can have a better view of the performance of my company. We have a lot of things that the companies already are using. Like, they might say, well, I want to look at the weekly, or I want to look at the monthly, or I want to look at these two sectors because I know that they probably perform differently. So I don't want to just look at the overall business. I want to look at these different groups because I know from my business domain that they perform differently. So you want to give the computer data and let the computer tell you which sectors perform differently. And so that's really what pattern recognition is all about. And it's really big in banking and finance, but it's really important for customers as well, customer segmentation, to be able to give a computer data and write a code that tells the computer, find me some really good splits from which you're seeing in the data, there are really different performers. And all of these separate groups, they're very distinct from each other, but within that group, they're very similar. And that's really what clustering and pattern recognition can give you. And so that's an important and emerging field for which there are no real rules, because it's not the same as linear regression, which we've all learned about. The rule for how your computer does it is simple, but the actual applications of it are endless. And I think it's something that has just become more and more important to companies. Suzanne, I just want to see what you have to say. So you have a PhD. Oh, wow, look at that. So you manage econometrics and statistics pretty well, but with structured data coming from surveys that I collect by others, that you collected by others. So you want to learn machine data to use with big data, machine learning to use with big data. Is this the focus of this course? Are all the regression models applied to big data? So it's not, Susanna, I would say that the models themselves are really just the coding of the underlying algorithm. It's not specifically a course that will connect you to like Google platform to do BigQuery or to just teach you how to work with large data sets. So I would say I work with large data, and some of the processes for handling and manipulating the data, or streaming data, or doing parallel processing are not part of this course. So if that's the specific need you have, is to learn how to do machine learning in the big data context. I think that may not, that's not covered in this course. So you might want to talk to program support about that. And I'm not sure if there's a big data course at Emeritus right now. It is something that is, it's always an issue. I think when I first started my first data science job, the first model that I wanted to run, which I felt very confident in the model itself, my Jupyter notebook had a memory error and I couldn't get past it. I couldn't run a very simple prediction algorithm because there was just, the data set was too big. And the type of data was very heavy in size, a lot of categories, categorical data. And so I immediately was hit with memory size issues and memory allocation issues, and getting an entire IT system to understand why I needed to either have more memory or move to the cloud, and then actually working in the cloud. And so I think the end point for those people who, like yourself, might already have the background in the modeling, but need to have more of a Amazon Web Services or Google Cloud Platform machine learning group. Because I think for us and our company, we had to just move what we were doing in our Python files and our Jupyter notebooks. We had to move that into the cloud and start working with things in a parallel way. And that wasn't something that there aren't that many courses for that. So it could be a challenge to find things that are just specific to working with large data sets and some of the problems that you encounter, from reading in a file by chunks, saving files by chunks, to actually, streaming and working in chunks. Another good example of the big data problem is work at a bank. I was talking with the head of data science at a bank, and they said, look, we don't even, two things. One, we're not creating new machine learning models because the regulations don't allow us to access a lot of data just for the sake of trial and error, or just for the sake of learning, or just for the sake of creating a new model. Like, we have to go through a lot of processes to get data. So we only really use data that has already been through that process. And two, you know, our biggest issue is we have to work in, I think what they were working in, I'm going to all of a sudden forget the name of it right now. They had to work in a way using a platform that allowed them to do parallel processing. And so they were looking for people that had that experience, because they were saying, you know, for us, there's nothing that we can do on a server or even in the cloud. We need to be able to do this using Spark. And so they were looking for people that had Apache Spark, which is very similar to Python in its actual outworking, but also takes place in a different environment. And so you have to already have that model working, but you have to be able to move it into a streaming environment. So Susanna, you're saying, what type of data do we use during the course? The data it varies. It's not, I mean, it's a mixture of toy data sets and real business data sets, real financial data sets. So data sets that you might see, we're not using proprietary data sets. So we're using data sets that have been made available. And so usually those data sets are going to be coming from research places like UCI, University of California, Irvine. We borrow data sets from Kaggle, which are fresh and are relevant, have a lot of background on. And I think from other things we might use are just like the same data sets for the basic like Python pandas development. You'll use some of the data sets that are available in pandas just to be able to do that, just so that you're able to like learn the basics of pandas data sets. I hope that's a good, trying to see a few other questions, so I'll answer those. So in the realm of AI environment, what machine learning topics does this course not cover? Well, I think the beginning, neural networks is a huge topic. I mean, neural networks is what a lot of people are thinking of when they're thinking of AI, especially with, I would say, reinforcement learning is something that is more AI. So I think machine learning is really, for me, although there's a lot of ways to describe the difference between machine learning and artificial intelligence, I think probably the simplest version that I've seen is that artificial intelligence is, you know, teaching computers to, you know, process things the way that we process things, the way that, or better than we process things. Machine learning is a tool of artificial intelligence. Machine learning is the prediction tools of artificial intelligence. But artificial intelligence is a system in which a multitude of prediction models are helping you move from where you are in the start to where you want to get as an end goal. And I think reinforcement learning or autonomous driving are good examples, because if you're in a car, the car might be an autonomous learning vehicle, and it's taking a snapshot of where it is, and it needs to make a prediction. Am I at a stop sign? Am I on a highway? Is there a person in front of me? What object am I seeing? And it needs to do an image recognition prediction model to say, what is this that I see? But then another thing picks up and says, based on this prediction, what is the right response? What are all the possible responses? And what is the best, most successful response? So there's a set of prediction models working in tandem to drive the car to say, I should turn left here, or I should turn right here, or I should keep straight. How left, if I'm turning left, how far left should I turn? All of those is a series of prediction models that give you an optimal number of, you know, or a kind of a set of choices, and then say, which is the optimal choice among my set of choices. So on the beginning, you need to have a prediction model that says, what do I think this is? What are all the possibilities that this is? And which one has the highest possibility? Based on that information, what are my options? List all the options. With each option, what is the most likely outcome? Based on the most likely outcomes, which is the optimal choice right now? And so you have to connect those series of predictions together, and you have to have, for reinforcement learning, you have to have a reward and penalty system. So building that, the reinforcement learning systems, I think, and just the overall like productization of machine learning is a lot of what artificial intelligence is. A lot of people say, oh, artificial intelligence is a chatbot. That's a good example of it. And I think it is, because when you go into a website, a customer service website, and a chatbot opens up, it will say something, and then you respond, and it has to make a prediction about your intent from your response. But then it has to determine what the best response is after predicting. And so it's using a lot of miniature prediction models along the way to have a conversation with you. So you respond and it tries to determine your intent, determine your needs, and then it has to give you back an optimal response. And so for me, artificial intelligence is any system that creates an optimal response based on a prediction. And that's kind of the differentiator. And so I think that the artificial intelligence is a lot more about the engineering side of creating optimal responses and creating a product out of machine learning. So I think that would be my answer to that. Adrian, as the program is offered by the engineering department, how real life are these applications as applied actual business problems and implications for the data science output for business? These, especially in the first part of the course, the material is really giving you the ability to manipulate data and to create functions. In the second part of the course, you're learning how to code the functions themselves. And so I think the coding itself is really the main aspect of this course. The applications themselves are not the main aspect of the course. You have applications to enhance your ability to code well, but the course itself is really your development of the algorithms rather than like some unique business case in banking or insurance or healthcare. So people are coming from a variety of areas, but the applications themselves are not the unique aspect of the course. I would say the algorithms and the intuition about the algorithms are probably the most unique aspect of the course. So I think if you have more questions, please do use the Q&A and I'll get to those as well, but I'll just jump back in here. So determining hidden parameters in the data to improve the accuracy of your model's predictions. I think that's a big part of machine learning as well, to be able to develop new parameters for business and to understand. A lot of times you're giving your model data, but I think a pretty good example of this is that you might have 1,000 rows that all have a very similar output, but the actual row information is varied. And so you might, either your X's are the same, but your Y's are different, or your X's are different and your Y's are the same. This is a really common case and you really need to identify that early on, but it's something that you don't really talk about in a lot of other courses. So sometimes the data that you have or the data you've been collecting there's not a lot of variation, but the outcome you're getting, there is a lot of variation. And so I think in econometrics, we would be thinking about what are the latent variables here. And sometimes the work to find latent variables and to get data, collect data is kind of its own course. Like, how can we create more data from our business that will help us find out, well, why were these two rows different? Because the outcome was certainly different. Is it random or is it non-random? We just don't have the data and we need to create that data. And then lastly, create probabilistic data models to predict a wide range of possible outcomes, accounting for real world risk and uncertainties. So I think we've covered that. Let me just go back to the Q&A and see what other questions you might have. Susanna, do we learn to code and work with unstructured data? Create models and regressions with structured data is quite easy, but with unstructured data, another story. Yeah, I think so. I think with the clustering data, with all of the unsupervised models, we're going to be working with unstructured data. I'm trying to think, because the current course we have has been reworked a little bit and we're not in that week yet. So I think I'm not sure about the applications for clustering, but I would say that the algorithms themselves are based on data that doesn't have any specific label or any specific structure in mind. So I do think that if you want to learn to work with unstructured data, it's probably a good starting point for that. Let's see what else. Okay, just a little bit about the learning experience. So it's a user-friendly platform. I think we work on Canvas, and it's very simple, very easy to use, even on mobile devices. There's live lectures delivered weekly, assignments with real-world applications, and this is something a lot of you are asking about, like what kind of real-world applications? I think all of the applications that we have are data that makes a lot of sense for a wide range of industries. But I think also, just a big part of real-world applications is, the basic data sets that you're going to be working with are definitely fit for the task at hand. They're not just wild data sets that we're like, what kind of problems are we trying to solve with this? They're specific to the problem we're trying to solve. So we have looked for data that does end up having clusters, so that when you're doing a clustering, you don't end up saying like, oh, there's only one cluster, which actually happens more often than not when I'm first starting a data clustering problem. I'll start with my data and I'll try and cluster it, and it'll turn out to be like 5 clusters that are all the same cluster, and then one unique set of 5 data points that's way off by itself in another cluster. And so I always bring that back to my team, and I'm like, well, we already know, but for online travel, a good example is when users are searching for hotels to book, like which cities do they want to book in? If you cluster the cities by search impressions, you'll get, 3 main clusters. Like you might want to say like, I want like 10 clusters because I want to work with 10 separate groups. So I want 10 clusters in a perfect world. But you'll get, 5 clusters are all together, and it's cities that no one searches for. Like they're just very small rural cities where there's a motel, but there's not a lot of searches for it on a daily or weekly basis. And then you'll get all the other cities that are somewhat like each other. And then you'll get Las Vegas, which is so far away because so many people search for Las Vegas hotels just to see what kind of hotels they are, or just to look at the hotel amenities and things like that. It's not necessarily that they all book Las Vegas hotels, but it is the most searched travel destination in the US. And so when you're clustering cities, you get lots of groups like you get your beach vacations right now. So even in this current situation where travel is restricted, it's not restricted for beaches. Like people are booking beaches. And so you have all of the beach cities are really high volume. And then all of the other cities are kind of the same. They just kind of have the same level of volume as each other. There's not a lot of variation. And then you have Las Vegas, which is way, way beyond any other city. It has so many people searching for Las Vegas hotels, Las Vegas 5-star hotels, Las Vegas casinos. And so when you're doing clustering, your initial cluster is like, you tell me what kind of city, how many city clusters there are. And there's really only 3. And it's disappointing because you just think, well, even among these clusters, there's got to be some other variation. And so it really takes like a conversation with your models where you're like trying to think, what are some other things that might, like maybe when I'm just looking at the last month of impressions, there's only 3 clusters, but maybe if I had some variable that was like the season's, Q1 impressions, Q2 impressions, Q3, maybe there would be a little more variation because summer rentals versus, winter holidays. Or maybe if I had yearly impressions, there would be some real standouts. And Las Vegas is always a standout, but then you start to get more dimension and more separation between your data and more clusters. So you just have to keep having this conversation. And I think that's something that we do talk about in unstructured data. So our learning facilitators, like myself, are subject matter experts, and we answer your questions related to course content and assignments during the online office hours. We provide feedback on your assignments. We moderate discussions to create more engaging course experience. We have a lot of back and forth just like this. I think that's, a second I was like, I think that's actually me in that picture. What to expect from each week. Bite-sized learning, time commitment, like we said, was 8 to 10 hours over 5 months. Assignments, quizzes, peer learning discussions, webinars, frequent course communication from us, learning facilitators, to guide you through the experience and to help you find the data or the type of tools you're looking for. Because a lot of this is about people bringing very unique needs to the course and saying, I love what I'm learning, but if I have this problem, where can I handle, like, where would I find this? And between the other peers and the course instructors or course facilitators, you end up being able to find it yourself and figure out where you need to go next. So the admissions process, I'll just go over that really quickly. Fill in the application and read through the learning material and sample test that you'll get back. Contact your program advisor for the pre-course admission test link. Take that test and then apply for the course. So there's an application, and then there's this pre-course admission test, which you can get a sample test to review it just to make sure that you're kind of ready for it. And then take the test and you can apply for the course. So after you register your interest for the course, you receive the set of sample questions. It's a PDF and it has an answer key so that you can kind of determine, did I get it right or not? So you'll use this to assess your familiarity with the basics of the course that you need: calculus, linear algebra, statistics, and probability. And then there's also some learning material so that you're just ready for the test. And then you reach out to the program advisor for the pre-course test. If you score 7 or more out of 10, then you'll benefit most out of the course's math-heavy content. So go ahead and register for the diploma using the application link that you'll receive from that. If you score below 7, you can take the test again, And if for some reason you consistently score below 7, then you might want to think about, I think my recommendation is we'll give you a set of links to some courses that are in statistics and probability that I think are through MIT, and they're the fundamentals. And if you can grasp those, then you'll come back and be able to take the test some further time. So participants who pass the assessment are ready to access the course, but if you don't pass a test, your program advisor will let you know what to do. So the program fee for the course is $2,350, and then there are flexible payment options. So you can pay it in full all at once. You can pay in 2 installments, and the first one is due immediately, and the final is due on the 24th of July. You can pay in 3 installments, and it would be immediately the 24th of July and the 23rd of August. So the program is going to start on the 24th of June, which is not very long from now, but our application deadline is the day before. So just think about what you need to do as far as preparing for the sample test and getting that accomplished before the 24th of June. The sample certificate will be partially from Emeritus and then partially from Columbia Engineering, Executive Education. And then it will be signed by both Bob Halperis and also the Senior Associate Dean of Undergraduate and Graduate Student Affairs, Columbia Engineering. That was a mouthful. So now I have a few questions and I want to get to those. I know we don't have very much time, so I'm just going to try and run through this. So what about XGBoost and Random Forest? We do cover Random Forest. I think we probably cover XGBoost, but it's something we always talk about. AdaBoost and XGBoost are something that I always talk about. How much of the course covers data manipulation? For example, if you're building time series, what kind of transformations give best results? So there's some level of data manipulation for time series, but I would say that's probably more of like a project of something that if you're interested in just doing time series, I think that could be something that we could go over. And then how long does part 1 and part 2 take? So 12 weeks for the first part and 12 weeks for the second part. So it's over 5 months total. And then is there any chance to access learning material after finishing the course? I think I'll let program support answer that in the chat box really quickly about how long you have after you finish the course, have access to the materials. Are there any other questions? I know we only have a few minutes left, so I just want to make sure that if there are questions, I get to them. Thank you so much for the questions, Susanna, especially. I know it's really hard to determine what is the best course to take depending on the specific needs you have. So I hope that I was able to answer those for you. Look in the chat box and see if there's anything else. So I think, Celie, I think you were asking follow-up regarding just from the chat box that you were asking about the type of follow-up for participants who have fallen behind. And I think there's messaging and then there's phone calls as well. If for some reason somebody slips, we also have, there are certain, you can get an extension from, if you have a need, like sometimes in this past few months, we've had some different job changes and some family health issues. And so people have needed to just take a week off to deal with some family issues. And in my experience, program support has been incredibly helpful, just saying like, we'll help you get through this and like get you back on track with an extension. So a possibility to follow as a group, example, your daughter and I. Follow. Christian, I think, if you can explain that question a little bit more. Is it possible to follow as a group? Like have a group of people together learning? Is that what you mean? 2 participants, yes. Yeah, I mean, I think program support could probably talk to you a little bit more about multiple people as far as certificates or diploma goes. I mean, one of the things I've always said to participants is that this is going to work best for you if you are teaching this to your peers and to your colleagues, or giving presentations to your colleagues and peers. And if everybody's kind of developing a learning system around it, it really cements it in for you, because the business questions that you'll get back will cause you to think like, okay, wait, I hadn't had that question. Let me go back to the course and back to the discussion board and ask if anybody else has done that. And so I think the best kind of situation is which you will be able to really like learn and teach the material alongside other people. But program support can talk to you specifically about having 2 learners at once, because it will follow your progress through as an individual. So if you complete it, it will be complete in your course module list and it won't be fresh. So that's just something to think about. So Sonak is also asking how long you have access to the course videos after completion. I wish I knew that answer. Okay, thanks, Christian, so much. Program support, I think if you can answer Sonak about how much access, how long the access is to the course videos after completion. I'd like to say it's probably longer than 6 months, but I'm not sure. And I'll stop the share on that. Hopefully the program support will be able to answer. I think that's all the time we have. So thank you so much for everybody for being here. I think if you have any questions, please just let program support know afterwards and talk to your applications administrator. And I will really welcome you to attend this course and hope that you found this webinar useful. Thank you so much.